Hi everyone. Today we're going to learn about transformations using parent graphs. In this directed learning activity, we're going to learn how to graph transformations of functions such as vertical shrinking and stretching, horizontal and vertical shifting and reflecting using parent graphs. Okay? We've talked about parent graphs of parabolas, square roots, cubic, and absolute value graphs. Okay? Here are the different types of parent graphs. Our first parent graph, okay, is y equals x squared, which is quadratic. Okay? That's a parabola. Okay, as you can see, parabola looks like a U. Your x values, okay, when you plug them in and you get x squared, here's what you come out with y, and it makes a U. Okay? The next kind is the parent graph of a square root. Okay, this is what a square root looks like. Now, notice here, your x values are all perfect squares. 0, 1, 4. Our next perfect square would be a 9. So you need perfect squares. Okay, now you plug it in. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Okay, when we plug in 0, 0, 1, 1, 4, 2, 4, 2, and then 9, 3. So 9, 3 would be somewhere up here. And you can see it makes a curve. That's a square root function. Okay, our next parent function is absolute value. Absolute value, as you can see, it looks like a V. Okay, here's our x values, -2 through 2. It looks like a V. And then our last parent function is cubic. Notice it's to the third power. We plug in 0, 0 to the third power is 0. -1 to the third power, it's odd, so our answer is -1. 1 to the third power is 1. If I plugged in 2 and -2, 2 to the third power is 8. -2 to the third power is -8. And let me show you how that would work. If I plug in 0, 0, -1, -1, 1, 1, okay, 2, 8, 2, 8, so it would be somewhere up here. And then -2, -8 would be somewhere down here. So you can see that it just continues. And that's what a cubic function would look like. Makes a curve like that. So here are your 4 parent values. Parent functions, excuse me. Okay. So now we're going to talk about certain kinds. The first type is stretching and shrinking using parent graphs, okay? Another word for shrinking is also called compression. Okay, now we can use stretching and shrinking for quadratic, square root, absolute value, or cubic, all right? If A is greater than 1, it's a stretch. So, greater than 1, it's a stretch. If it's a fraction, it's a shrink. Okay? So, if it's greater than 1, it's a stretch. If it's a fraction, see, between 0 and 1, it's a shrink. Okay? Let's look at our example. You can see here, okay, get some different colors. Y equals x squared. The y equals x squared is our parent graph, and that is in yellow. Okay. Then you have y equals 1/2 x squared. I'll make that in green. Okay, that's y equals 1/2 x squared. And then y equals 2x squared, I'll make that in pink. So now you can see here, just from what your previous knowledge is that remember fractions are fat? Look at the 1/2 x squared. See how this is wider than the 2x squared and the 1x squared? Okay. So basically you could see here that the 2x squared, you multiply the y coordinates by 2. So to get from, again, this is the parent table, right? Y equals x squared, that's your parent. And to go to the 2x squared, which we know is a skinnier graph, if you multiply the y's by 2, okay, you get a skinnier graph. If you multiply the y's by 1/2 or divide by 2, you get a wider graph. Okay. Our next type is called reflection. Okay, reflection about the x-axis using parent graphs. Okay, that's what you say, reflection about the x-axis. Again, now with reflection, it's negative. Okay, and again, we can use it with quadratic, square root, absolute value, or cubic. Okay, it's the function y equals negative f over x, where it's reflected about the x-axis. Again, about the x-axis. The negative in front of the function reverses every sign. So, here is our new graph. So you can see our parent graph, which we'll keep in, oh, here's our parent graph. Okay, which is here. And now look at our new graph, which is reflected. Same thing, but negative. See, because of the negative. And all that happens is the y's are reversed. It's always the negative. Okay, that's what happens. Okay, so again, this is called reflection. So that's reflection. Next. The next kind is a horizontal shift using parent graphs. Okay, here's the key to horizontal. Your x is opposite. Can you see that? Yes. Your x is opposite. Okay, so in the horizontal graph, see that? See the h there? That is opposite. That is the opposite in here. All right? So x squared, which is quadratic, square root, absolute value, cubic. If the function y equals f parentheses x plus h, okay, see how that's opposite? So then it's shifted to the left. Here, it's negative h, so it's shifted to the right. Okay, so look at our first example. Again, the key is opposite. Here are two examples. Our first example, we have x minus 3 to the second power. So what's our key here? We need to take the opposite. So that's negative 3, so it shifted right. So our new graph, okay, here's our new graph. This is our new graph. So our new graph is now shifted right. This is our new graph. Okay, here's our parent graph, right? This is the parent graph. Use this as the parent. That's the parent. Make sure you can see that. Yes. Okay, here's our parent. And then our new graph says negative 3, so we do the opposite, which is positive 3. Does not look like vertex form, people, where we take the opposite. Okay? And you can see, how do we get from here to here? We just add 3 units to the x coordinate. Okay, look at this problem. Again, our parent graph is y equals x squared, and now we have x plus 3, so we do the opposite, which is 3 left. Okay, and then again, here's our parent graph. Okay, so what are we doing here? How do we get from here to here? We need to subtract 3. To the x values. Okay, so again, horizontal, what's the key to horizontal shifts? Opposite. X is opposite. Okay. So, horizontal shifts, x is opposite. Well, our next page is vertical shifts. So what do we do for vertical shifts? Vertical shifts is vertical shifts. And what do you think I'm going to write for vertical shifts? Y is as is. Sounds familiar. Okay, so vertical shifts, y is as is. Okay, so here's our k. Here's our k, and that's as is. Same thing. Quadratic, square root, absolute value, or cubic. So here's plus k going up, minus k going down. So here's our first problem. X squared plus 2. What are we going to do? We're going to go up 2, as is. Here is our parent graph in green, up 2. So our y-intercept, up 2. Okay, and again, here's our parent graph in green. And then our next graph. Oh, by the way, what do we do? Sorry, from the x's, how do we get from x squared to x squared plus 2? We added 2 units to the y value. All right, and then our next problem, x squared minus 2, we shifted down 2 units, which you can see. Okay. And what do we do here? We subtracted 2 units to the y values. Okay, so again, horizontal, do the opposite, vertical, as is. Okay, so now we're going to talk about absolute value. Okay, absolute value is a V-shaped graph, and here's the key here. Okay, here's the formula. The equation, excuse me. Okay, the A in absolute value determines up or down or the slope. Again, we have to take the opposite of H, and K is as is. So, let's do a few problems here. How do we transform the graph of the parent function? Okay, so the first thing we want to find is the vertex. Okay, so what are we doing here? Here we're going to do the opposite, so we're going to go left 4 and down 1. Right? Left 4, opposite, and down 1. Okay? Let's try another one. On this problem, how are we going here? We're going right 3, up 7, right 3, up 7, and now we have a 3 here. Okay, now what did we say about a 3? It's a number, it's not a fraction, so it's a vertical stretch. vertical stretch by 3. Can we see that? Okay. Number 3. Okay, first one, right 2, up 4. All right, and what are we doing here? It's a vertical stretch by 5, but see the negative here? What do we say about a negative? It's reflected about the x-axis. You could say over the x-axis. X-axis. About or over, you could say either word. Okay, so there's 4 things that we did here. Up 2, excuse me, not up 2, my bad. Right 2, up 4, vertical stretch of 5, and because of the negative, it's reflected about the x-axis. Okay, let's try this one. Okay, and you're going to see there's 4 things here as well. First thing, left 12, up 12. Okay, now, because there's a fraction, it's a vertical shrink. Okay, or vertical compression, either word. Vertical shrink, okay, by 3/4. And then, because of the negative, you want to say reflected over the x-axis. It says reflected. Okay, so again, if there's a negative, you have to say it's reflected over the x-axis or about, either word you could say. All right, let's try graphing. Okay, now, don't be intimidated by the graphs. Let's do the first thing of domain and range and the vertex. Okay, so what's my vertex? Well, my vertex here is 0, 2. How did I get 0? Because there's nothing in here, nothing in the x, and then we go up 2. So simple. Now, how do I draw this? Okay, well, if you look back up here, the A determines the slope. So what number is in front of here? The number in front of here is just a 1. So we're going to go up 1, over 1, up 1, over 1. And there you go. Wasn't that easy? All right, now the domain. What do we say about domain of all these kind of problems? All real numbers. And the range, y such that y, pointing up, so greater than or equal to, y value of the vertex. Sound familiar? Next. All right, what's my vertex? My vertex is 4, opposite as is, so 4, 0. What's my slope? My slope is -1. So, down 1, over 1, down 1, over 1. Okay, domain again, all real numbers. And range, y such that y is pointing down, less than or equal to y value of the vertex. Okay. We're gonna, no, we'll do number 3. Okay, vertex 0, 5. Slope, -3. See how the slope is -3? Down 3 over 1. Down 3, 1, 2, 3 over 1. 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 See that? Look how easy that problem is. Okay, domain all real numbers. range y such that y pointing down less than or equal to y by the vertex. All right. Okay, let's do number 9. We're going to skip. We'll do number 9, and we have vertex 2, 3. 2, 1, 2, 3. Vertex is 2, 3. And my slope is negative 2. Down 2 over 1, down 2 over 1. Down 2 over 1, down 2 over 1. Domain all real numbers. And range y such that y is less than or equal to y by the vertex. And we'll do the last one. Vertex, negative 1, negative 5. Negative 1, negative 5. Slope 2/3. Up 2, 1, 2 over 3. 1, 2, 3. Up 2 over 3. 1, 2, 3. Okay, let's go to the other side. Up 2 over 3. 1, 2, 3. Up 2 over 3. 1, 2, 1, 2, 3. Okay, all real numbers. Y such that y is greater than or equal to y by the vertex, negative 5. Okay, so there are some problems on absolute value. Okay, last problems we're going to do. Okay, we're going to compare the parent graphs to the transformations. Okay, what kind is this? You should know x to the second power. It's quadratic. So the parent graph is x squared. How did we get from x squared to x squared minus 6? We just went down 6. Okay, that's all you have to know. All right, how am I going to graph this? Well, you know it's quadratic. You know it's going to look like a U. All right, so in order to figure that out, we need an xy table. And what should I use? 0, 1, and 2. You should realize from looking at this, your vertex is 0, negative 6. That's your vertex. All right, plug it in. 1 minus 6, negative 5. 2 squared is 4 minus 6, negative 2. And plot. And then 2, negative 2. Okay. And there's my parabola. You should also realize that your axis of symmetry is 0. So that's quadratic. All right, next, absolute value. We did plenty of those. Parent graph, f of x equals absolute value of x. How did we get from here to here? Is the opposite, so right 1. Okay? So now, I don't even need to do an xy table because I should be able to look at it and realize that my vertex is opposite as is, 1, 0. And then what's my slope? My slope is 1. Up 1, over 1. Up 1, over 1. Done. Okay, next one. Square root. Okay, so a square root's a little different. Not that it's different, it's just you have to be mindful here. Okay, parent graph is just absolute value of x. And if you're confused, what's the parent graph? Located on the very first page of our notes on this video. Okay, how did I get from here to here? This is a vertical translation. We went up 4. Okay, so I need an xy table here. Now remember, I need perfect squares here. So if I need perfect squares, what are my perfect squares? 0, 1, 4, 9. So plug in. Square root of 0 is 0, plus 4 is 4. Square root of 1 is 1, plus 4 is 5. Square root of 4 is 2, plus 4 is 6. Square root of 9 is 3, plus 4 is 7. Good enough. And plot. 0, 4. 1, 2, 3, 4. 1, 5. 4, 6. 1, 2, 3, 4. 6. And 9, 7. And notice something here, okay? It's always array. And the domain here, just to let you guys know, x such that x is greater than or equal to 0. Sorry, greater than or equal to 0. And the range would be y such that y is